Imagine a world where summer is not a season of beach trips and ice cream, but a yearly sentence of physical exhaustion. Before the late 19th century, when the mercury rose, humanity simply ground to a halt. In crowded, unventilated brick tenements and stagnant offices, the heat was more than an inconvenience. It was a public health crisis that drained productivity and claimed lives. For thousands of years, our ancestors fought back with feathers, folded paper, and sheer muscle power. But the breeze they generated was fleeting, expensive, and deeply inefficient. Then came a quiet revolution. It didn't rely on muscles or servants, but on a newly harnessed invisible force, electricity. This is the incredibly detailed story of the electric fan, an invention that didn't just cool our skin, but fundamentally reshaped where we could live, how we built our cities, and how we conquered the global climate. To truly appreciate the electric fan, we must first understand the sheer desperation of the pre-electric era. Humanity has always been obsessed with moving air. In ancient Egypt, pharaohs relied on servants waving massive lotus leaves or palm fronds. In India, the wealthy stayed cool using the punkah, a large rectangular frame covered with canvas or heavy cloth suspended from the ceiling. To make it work, a servant known as a punkahwala sat outside the room or in a corner, pulling a system of ropes and pulleys for hours on end to swing the heavy frame back and forth. It was slow, rhythmic, and entirely dependent on human exploitation. The earliest mechanical attempt at continuous air movement dates back to the Han Dynasty in China around 180 AD. An ingenious inventor named Ding Huan created a rotary fan featuring 7 massive wheels, each about 3 meters in diameter. It was operated manually by prisoners or laborers turning a crank. While it could cool an entire hall, it was massive, loud, and completely impractical for an average home. Humanity was trapped in a cycle of sweltering stagnation, waiting for a compact, self-contained power source. The breakthrough happened in a flash of late 19th century American innovation. The place was New York City. The year was 1882. A brilliant 22-year-old electrical engineer named Schuyler Wheeler was working as an assistant to Thomas Edison. Wheeler was fascinated by the potential of electric motors, which were then in their absolute infancy. He realized that if an electric motor could turn a shaft to run a factory machine, it could also turn a small propeller to move the air. Wheeler took a small double-pole electric motor manufactured by the Crocker-Wheeler Company and attached a crude two-bladed metal propeller to the spinning shaft. It had no speed controls, no off switch other than pulling the bare wires out of the power source, and absolutely no safety features.
To look at Wheeler's original fan today is to look at a beautiful, terrifying contraption. The blades were made of heavy, unshielded brass. They spun at high speeds, completely exposed to anyone walking by. If a curious child or an inattentive office worker got too close, the heavy metal blades could easily sever a finger. Despite the danger, the invention was an instant sensation. For the first time in human history, a person could turn a dial and receive a continuous, artificial, tireless breeze. The early models were sold primarily to wealthy offices, government buildings, and high-end hotels in New York and Boston. The electric fan had officially entered the world, but it was still a luxury item, and it was strictly bound to desks and tables. While Schuyler Wheeler's desk fan was taking over offices, another inventor was looking at the ceiling. In 1887, a German-American mechanical engineer named Philip Diehl took the electric fan to its logical next step. Diehl had worked for the Singer Manufacturing Company, designing electric motors for sewing machines. He realized that a sewing machine motor was incredibly compact and powerful. Diehl took one of these sewing machine motors, mounted it to the ceiling, and attached 2 pairs of wooden blades directly to the rotating housing. By mounting the fan overhead, Diehl solved several massive problems at once. Space saving, it kept the bulky machine off desks and tables. Safety, it hoisted the spinning, dangerous blades far out of reach of curious hands. Physics of airflow, It utilized natural convection, pushing rising warm air down and circulating air throughout an entire room rather than just a single direct beam. Diehl's ceiling fan was patented in 1887. He didn't stop there. He soon added an integrated light fixture to the bottom of the unit, creating the very first combination light and fan fixture. The ceiling fan exploded in popularity, quickly becoming a staple in retail shops, restaurants, and grand railway stations across the globe. If you're fascinated by the hidden histories of the everyday technologies that make modern life livable, do not let this breeze pass you by. Take a quick moment to hit that subscribe button, give this video a thumbs up, and turn on notifications. It helps support the deep dive research that goes into creating these incredibly detailed histories. Now, let's get back to the golden age of wind. As the 20th century dawned, the electric fan transitioned from a novelty for the ultra-wealthy into a household necessity. But to conquer the mass market, manufacturers had to solve two major issues: safety and distribution.
Between 1890 and 1910, manufacturers began addressing the safety hazards of exposed blades. The first protective cages were crude, wide-spaced iron wires that could stop a whole hand but still let fingers slip through. Over the decades, these cages evolved into intricate spiderweb-like designs made of gleaming brass, which eventually gave way to tightly woven steel mesh. Early fans blew air in a single rigid direction. If you sat directly in front of it, you got cold. If you sat 2 feet to the side, you sweltered. To fix this, engineers introduced the oscillating fan in the early 1900s. By using a clever system of reduction gears connected to the main motor shaft, the fan head was forced to slowly rotate back and forth on its base. This swept the breeze across an entire room, mimicking a natural rolling wind and preventing the direct drying blast of a stationary fan. During the first 3 decades of the 1900s, electric fans were built like tanks. They featured heavy cast-iron bases to prevent them from vibrating off tables, and their motors were wound with thick copper wire. The blades were of solid, polished brass. However, by the late 1930s and early 1940s, the design philosophy shifted. As the world entered the Art Deco movement, manufacturers like Emerson, Westinghouse, and General Electric began using lightweight aluminum and early plastics like Bakelite. Fans became sleeker, quieter, more colorful, and far more affordable for the average middle-class family. By the 1940s and 50s, the electric fan faced its greatest existential threat: the rise of residential air conditioning. Invented by Willis Carrier in the early 20th century, air conditioning units actually cooled and dehumidified the air, rather than just moving it. As central air and window units became affordable in the post-World War II housing boom, many predicted the death of the electric fan. But the fan didn't die. It adapted. In the mid-1940s, a company called Vornado revolutionized fan physics. Instead of simply pushing air outward in a flat wall, they designed a fan casing modeled after airplane engines. Using a deep-pitched blade, a unique duct system, and a spiraled grill, the Vornado fan created a tight, swirling vortex of air that could travel across an entire room, bounce off the opposite wall, and circulate the air in the whole space. They called it one whole room air circulation, and it proved that a well-designed fan could work with an air conditioner to distribute cool air more efficiently, saving massive amounts of electricity. As we entered the late 20th and early 21st centuries, the electric fan underwent its most radical aesthetic and functional transformations. By the 70s and 80s, high-quality metals were largely replaced by molded plastics. While these fans lacked the heirloom durability of their cast-iron ancestors, they were incredibly cheap to manufacture, lightweight, and entirely rust-proof. This era also introduced electronic timers, remote controls, and multi-speed microprocessors. In 2009, British inventor James Dyson shocked the consumer electronics world by releasing the Dyson Air Multiplier, the world's first truly bladeless commercial fan. To the casual observer, it looked like magic, a hollow plastic ring that blew a continuous, powerful stream of smooth air with absolutely no visible moving parts. The physics behind it, however, was pure genius. The hidden motor. A high-efficiency brushless motor was hidden away in the base of the unit, drawing air in through tiny compressor-like vents. The airway ramp. This air was pushed up into the hollow ring and forced out through a microscopic 1.0 millimeter slit running along the inside edge of the hoop. Coandă effect and entrainment. The air traveled over an airfoil-shaped ramp inside the ring. As it did, it created a low-pressure area behind the ring, drawing the surrounding air into the stream, a process called entrainment. This multiplied the initial volume of air drawn into the base by up to 15 times, creating a perfectly smooth, buffet-free breeze. Today, fans continue to evolve. Modern smart fans connect to home Wi-Fi networks, adjust their speeds based on local weather reports, and utilize highly efficient DC motors that use a fraction of the electricity consumed by Schuyler Wheeler's original 1882 motor. From a dangerous two-bladed brass propeller rigged to a sewing machine motor, to whisper-quiet smart devices that analyze room temperatures in real time, the electric fan is a testament to human ingenuity. It did not just make us comfortable, it made modern office work possible, allowed cities to flourish in equatorial climates, and paved the way for the modern world. The next time you flip a switch and feel a cool, immediate breeze wash over your face, take a moment to thank Schuyler Wheeler, Philip Diehl, and the century of engineers who dedicated their lives to taming the heat. If you loved this deep dive into the fascinating history of the electric fan, please leave a comment down below telling us what everyday object's history you want us to unearth next. Share this with a friend who can't sleep without their fan on, and don't forget to subscribe for more incredibly detailed, educational journeys through the history of human innovation. Keep cool, and we will see you in the next chapter.